Welcome once again to the online lecture of B.Sc. second year analytical chemistry. This is Mr. Shindya Chitram Rao, working as an assistant professor, Department of Analytical Chemistry, Sanjeevani Mahavidyalaya Chapoli. Student friends, in last lecture we have learned about the different spectroscopic instrumentation as well as the Lambert's law as well as the different component of the spectrophotometer. But in this lecture we are going to deal with the new topic, that is nothing but the systematic diagram and working of double beam photoelectric colorimeter. Before going to this topic, it is necessary to see the some terminologies as well as the what is the single beam spectrophotometer, what is the double beam spectrophotometer, photometer, and some uh, the terminologies like colorimetry is there, photoelectric colorimetry is there, what is the so let's see the instrument. The instrument is instrumentation is fully based upon the Lambert's law, is the fundamental law governing the absorbance of the monochromatic radiation by homogeneous transparent system. On the basis of this law, the techniques employed for the measurement by instrument called as colorimetry and spectrophotometry. What is the Lambert's law? Lambert's law states that that is what the uh, it states the relationship between the absorbance and the transmittance. So it is absorbance is one, that is the inverse of transmittance. Then how the that absorptivity coefficient is related with the absorption. So absorption and transmission, when you measure the absorbance, will get the exactly we will get the transmittance, that is it is the inverse of the absorbance. So this instrumentation is based upon the uh, these principles, that is Lambert's B.S. law. Next, see after that the what is the colorimetry and the photoelectric colorimeter is there. So colorimetry is it is the simplest form of the absorption analysis, the technique which is concerned with the determination of what the concentration of the substance by measurement of the relative absorption of the light with respect to known concentration of the substance is called as colorimetry. In colorimetry, we measure the absorbance, the which is function of the concentration, but known concentration is required for the what colorimetry. But what is the photoelectric colorimeter? The instrument which have a photoelectric device instead of eye, we use the photoelectric device as a detector, as well as eye instead of the eye are used in the what visible region in the colorimeters. It is also associated with the different types of the filters of the wavelength and this. So we know this filter photometer or photoelectric color photometer. So the sensitivity of the instrument is considerably enhanced with the use of photoelectric detector. Two types of the photoelectric colorimeters are in the use, that is single beam and double beam. So what is the difference between colorimeter and the photoelectric colorimeter is that in the photoelectric colorimeter we use the photoelectric device as a detector instead of eye, and we use the filters or filter photometers, and which enhances the sensitivity of the instrument rather than that in the that is in the colorimetry. So generally two types of the instrument use, that is nothing but that is the uh, single beam and double beam photoelectric colorimeter. Then what is the single beam instrument, what is the double beam instrument, what is the difference between these to single beam and double beam instrument. See, in the given diagram, see here what the different component are given as what the single beam uh, photoelectric colorimeter. So single beam photoelectric colorimeter, what is it associated with in which component? Which components are included in the single beam, and what is the difference between the single beam and double beam? So in single beam photoelectric colorimeter, in the modern instrument of the colorimeter, the intensity of the transmitted radiation is measured by the photoelectric cell. Such colorimeter are called as a photoelectric colorimeter. What is the photoelectric colorimeter? Here we measure the intensity of transmitted light. Here what? Measure the intensity of transmitted light by the help of photoelectric cells. So such colorimeters are called as photoelectric colorimeter. Colorimeters means we determine the color, we measure the color, absorbance of the color. So what is absorbance? If we measure absorbance, we will get the transmitter. Exactly, we get the transmittance. So we measure the intensity of transmitted light by using photoelectric cells in the case of the uh, photoelectric colorimeter with the help of photoelectric cells. These are the detectors. So see what is the diagram for this. First one is this is what the source of radiation, that is UV radiation. This is lens, and see how this is lenses for the what emerging beam, and this T is the filter, F is the filter, and here cuvette is there for the keeping sample or putting sample in the path of the light, and here uh, the galvanometer is that, and photoelectric cell is the what detector. So see how this uh, the essential component of a single beam photoelectric colorimeter are a source of light. First one is the what? Source of light. And what is the source of light? It is a tungsten lamp. Source of light is nothing but a tungsten lamp held in the concave reflector, a collimating lenses. And the first one is the source of light. This is nothing but tungsten. This is the what? Tungsten lamp. It is the source of UV light or visible light. So uh, a collimating lenses, this is the collimating lenses. We what for the what lenses are used for the what purpose? To emerging the beam of the radiation. The next one is the galvanometer G, and an adjustable diaphragm. This is the what? The diaphragm for adjusting the beam, and here the galvanometer to measure the transmittance. Then a colored glass filter for monochromating monochromating light. That is what the what for monochromator means what? So we'll get the single wavelength light. So for the monochromatizing the given beam or light beam, we use the colored glasses or filters to what absorb the other types of the wavelength, and what the will get the desired wavelength for the measurement, or the that is the UV wavelength for the measurement. Then next one is cuvette for the holding the absorbing solution, and the last, that is barrier type of cell P, that is nothing but detector, photoelectric photo cell for the detection. So what is the entire the instrumentation is there, how this entire instrumentation is explained. This is what the source of UV radiation. It is tungsten lamp. This is the lenses, collimating lenses. And this is the one emerging beam from the source, and it falls on the what lenses. And this is what adjustable diaphragm for the beam. This is the colored glass filters which absorb the other type of radiation and allows only one single type of monochromatic radiation. This is the cuvette which holds the sample and this is the what the P is the photovoltaic cell for the it is a. So what is the uh, working, what is the barrier cell, what is the galvanometer, what is the, see, the essential part of this uh, what the photoelectric colorimeter, a single beam photoelectric colorimeter is the source of radiation, collimating lenses, as well as the diaphragm, adjustable diaphragm, and color gas splitter for the monochromatizing the light, and cuvette for the holding the solution or absorbing the solution, and the P is the barrier type of the photocell, which is used for the measuring the or the detection of the transmittance. Then what is the working of this what the instrument is the cuvette is first fitted with the appropriate blank solvent, that is nothing but the water cuvette. This cuvette is what fitted with the what the this cuvette. This cuvette is fitted with the water and kept in the path of the or placed in the path optical path, or path of the light optical. Then this absorbance is a 0% because the solution is blank, and 100% transmittance will get if we put the cuvette, that is nothing but a black body radiation or black cuvette, will get the 100% absorbance and 0% transmittance. Adjust these 100% transmittance or 0% absorbance by keeping or by placing the appropriate blank solvent solution in the cuvette and into the optical path. After that, this adjustment, after the adjustment of 10% transmit, 100% transmittance and 0% absorbance, then fill the cuvette with the solution whose absorbance is to be desired. Then after what filling this cuvette, place this cuvette into the path of the radiation, and then this radiation is get absorbed, and this is nothing but the its percentage transmittance and or absorbance is measured, which is nothing but optical density, nothing but the absorbance. And with the help of this absorbance we can calculate the transmittance. The concentration of the sample solution can be determined using Beer's Lambert's equation. So if you measure the series or to prepare the series of solution of different concentration, and by measuring the absorbance, that is optical density of the standard solution, we can determine the, by plotting graph we can determine the what absorbance of the unknown solution. So this is about the what it is nothing but lambda max. The next type of the instrument is the double beam photoelectric colorimeter. What is the difference between double beam and single beam? Here what double beam is used, double beam of the radiation means what, the beam of radiation passes through the reference solution as well as the sample solution, whose reference solution is a standard solution whose concentration is to be what concentration is known, and sample solution is the unknown solution whose absorbance we are going to measure the absorbance of the transmittance. So in order to operate this instrument, the null balance galvanometer is adjusted mechanically to bring the needle at the mid scale with the lamp off. Means what, here what the galvanometer is what maintained at the 0 position, adjusted at the 0 position when lamp is off. Then the lamp is switched on and blank solution is kept in both light beams. So if we then if what the we here what the when the lamp is off, here lamp is off, we adjust the galvanometer needle to 0 mechanically, and after switch on the lamp, firstly keep the that is nothing but the blank solution to both the beam, that is reference beam and the what the sample beam. So and adjust solution is kept in the both light beams. So after adjusting the uh, that is adjusting the uh, transmittance to 100% and absorbance to 0%, uh, put or place the solution into that is the sample cell as well as reference cell in the path of the light. So we will get the potentiometer, that is dial R2 is adjusted to read 100% transmittance. Here what adjust the for double beams coloring photo electric colorimeter to 100% transmittance, and then side wire contact R1 is adjusted to null the galvanometer. So R2 and R1 are the uh, resistance which is what used to adjust the 100% transmittance as well as the uh, null position of galvanometer. The standard and unknown solutions are what introduced into the measurement beam and sidewire contact R2 is adjusted to the renull the meter. The transmittance linear or absorbance non-linear can then be read out from the photometer dial for each sample. So what happened? This procedure is what carry out uh, in many times for the different types of the solutions, that is having the different concentration. We'll get the uh, curve, that is absorbance versus the concentration, and that is the transmittance linear or the absorbance non-linear. So depending upon the concentration we will get the different type of the reading, that is optical densities, and with the help of that we was prepared the prepare the graph, that is calibration curve. A linear curve is obtained or non-linear curve is obtained by adjusting the null position of the galvanometer by using R1 and adjusting the 100% transmittance by R2. So by keeping different types of these solution, different concentration solution, we can adjust the what how we can able to measure the intensity of the transmitted light. This is about what, but here what we passes the solution, the beam into reference as well as the what the sample solution. So 2 times beam is what passes through the solution, that is in the reference as well as in the sample. See here what the this passing of this beam by mirror, that is a deflection of the beam and passed through the what this reference solution, and then R2 this is used resistance is used to what the transmittance to 100% cell is R1. It is used to what adjust the galvanometer reading to 0, that is null position, initial null, and this radiation passes through the what sample and it is fall on the detector, and this is measured. So this is about the what working of this double beam spectrophotometer. What is the advantages of double beam instrument over the single beam? So although double beam instruments are more complicated and expensive, they do offer the following advantages. What are the advantages? It is not necessary to continually replace the blank with the sample or adjust zero absorbance at each wavelength as in a single beam unit. So here it is not to what adjust every time, that is the transmittance 100% as done in the single beam apparatus. Here automatically what one time the what the transmittance is what settle, that is set it is what equal to 100, then there is no need to further adjust the uh, transmittance to 100%. So it is not necessary to continually replace or blank with the sample and what the to adjust the zero absorbance to each wavelength in a single beam units. So the ratio of the powers of sample and reference beam is continuously obtained and use any that is used. So any error due to the variation in the intensity of the source and function in the detector is minimized. Here what the there is a what negligence of the error in the what the intensity of the source or fluctuation of the intensity of the source of radiation. Because of the previous two factors, the double beam system trains itself to rapid scanning over a wide wavelength region to use the recorder uh, record or digital readout. So here no need to replace or what adjust the transmittance to 100% every time, as well as there is no fluctuation in the intensity of the beam. So this is what the two advantages of this double beam over the single beam. So it rapidly scanning or rapid scanning over the wide wavelength region. So this is the what better techniques than the single beam. Then the next point is the what the difference between the uh, photometer and spectrophotometer, as well as the colorimeter. What are the difference between these? What is photometer, what is colorimeter, and what is the spectrophotometer? We will see in the next lecture. Thank you. Thanks a lot. Keep watching.